Okay, so we're going to go into what we call an extension of the trigonometric ratios, or trigonometry. What we're going to do is we're going to extend the concepts of trigonometry to include all triangles, not just right triangles. And what we're going to do is we're going to do that through the law of sines. Okay? So you can only imagine that as people began to understand what trigonometry did and the ratios that trigonometry represented in the concept and how it helped them to calculate the measurements of the sides of right triangles, they began to see how in the world and to push the envelope of this and to extend it to see if it could be used for other types of triangles. So they began to experiment and play with creating right triangles out of other types of triangles and came up with some methods. So we're going to start with a triangle ABC that is not a right triangle, and we've got A over here, point A, and across from it we have side A. We have point B, and across from it side B, and we have point C, and across from it side C. And we're going to drop a altitude from point C to the opposite side, AB, okay? And where it crosses a side AB, or segment AB, we're going to call that D, and we're going to call that H, okay? So we're going to play with this and see what we can come up with. We know that the sine of A equals H divided by B, the hypotenuse of this right triangle. Because we created two right triangles, and we can use those right triangles in trigonometric ratios with those right triangles. So we know the side of A equals H divided by B. Okay? Now, we'd like to show that, get H by itself, and so we can do that by multiplying both sides by B. When we multiply this side by B, we end up with B sine of A equals H divided by B times B. Well, over here, the B's go to 1, and we're left with B sine of A equals H. So we have an H by itself. Now over here, we can go sine of B equals H divided by A. Sine of B equals H, the opposite side, divided by the hypotenuse. Again, we want to get H by itself, so we're going to multiply both sides by A. We get A sine of B equals H divided by A times A. The A drops to 1, and we're ending up with A sine of B equals H. Now both of those equal H. If two things equal the same thing, then they are equal to each other. That's a transitive property of algebra. Okay? Concept of A equals B, B equals C, then A equals C. Or, in this case, substitution. If A equals B and C equals B, then they both equal B. So basically we have this right here. B sine of A equals H, A sine of B equals H, and we can set those equal to each other. So let's do that, and then we're going to play with that just a little bit and see what happens. So let's set those equal to each other. When we set those equal to each other, we have B sine of A equals A sine of B. Now, if we'll come along and we divide both sides, let's divide both sides, play some games, and let's divide both sides by AB. We can do anything to an equation as long as we do it to both sides. All we're doing is playing magic games with algebra, with equations. We did it with both sides. Now, what happens over here? The B's disappear, and we're left with what? The sine of A divided by the measure of segment A. Equals, and what happens over here? The A's drop out, and we're left with sine of B divided by segment B. Okay? So we end up with a proportion. Our two ratios set equal to each other, create the cross products, and then we can, if we know three of those, we can find the others. Now, if we were to use similar methods, we could also show that sine of A divided by A equals the sine of C divided by C, and the sine of B divided by B equals the sine of C divided by C. We could go through that proof and solve that too, and show that. So what we end up with is this. the sine of A divided by A, this is an angle, equals the sine of B, an angle, divided by B, equals the sine of C divided by C. Or we can flip all of those upside down, and the measurement A divided by the sine of A equals measurement B divided by the sine of B equals the measurement of C divided by the sine of C. Okay? And that way we can solve any type of triangle. It no longer has to be a right triangle. Because what we did was we created two right triangles and used H and extended it to include all types of triangles. Now what we're going to do is actually use the law of sines to do what is called solve a triangle. Okay, whenever we solve a triangle, we take the information that we're given and then we find all the rest of the missing information. There are three angles and there are three sides. So to solve that triangle means that we're going to find how many ever the sides are that are missing, and then we're also going to find the angles that are missing. And that's what we're going to do here. Given the law of sines, okay, the law of sines is sine of A divided by segment A, sine of B divided by segment B, sine of C divided by segment C. Those are all equal ratios. And we can flip those over, just turn them over. The magic of algebra, just flip those over, and A divided by the sine of A equals B divided by the sine of B equals C divided by the sine of C. Those may be easier ratios for you to use. Now, we're going to solve triangle DEF. That means find the missing angles and sides. So that's exactly what we're going to do, is we're going to solve this by finding the missing angles and sides. Okay? So what are we given? Well, we're given that the measurement of angle D equals 33. We're also given that the measure of angle E equals 47, and that E is 14. Okay? Pretty simple. Let's actually draw that over here so we can actually see it. Okay? It's got a triangle over here. Make sure, oh, it almost looks right, but we're going to go D, E, F. So across over here would be little d, across from the E would be little e, and across from the F would be little f. We know that this is 33 degrees. We know that E is 47 degrees. And we know that little e equals 14. Well, we can find what angle F is, the measurement of angle F. How? We can simply take 180 minus 33 minus 47, and that equals 100. So what we've got here is this is 100 degrees. So that was easy to solve. Stuff we learned way back when. Now let's look at how we use the law of sines to find the other missing pieces, which is we don't know what D is and we don't know what F is. Side D and side F. So I'm going to use this D divided by the sine of D equals side E divided by the sine of E. Okay? Well, we don't know what D is, that's what we're trying to find out. The sine of D, well, that's the sine of 33 degrees, equals, we know what little e is, it's 14, and we know what the sine of E is, it's 47. So we know 3 out of those 4. If we simply multiply both sides of this, okay, with sine of 33, that's going to go away here and it's going to put it right up there on top. So we end up with D equals 14 times the sine of 33 divided by the sine of 47. We do that math 14 times, get the sine of 33, multiply that, and divide it by the sine of 47. We find out that D actually equals 10.43, whatever that measurement is in units of measure. Okay? So we've now found what D is. Let's go over here and find F. We know that F divided by the sine of F is going to equal E divided by the sine of E. Okay? We're trying to find the side F, little f, divided by the sine of. We know that that angle is 100, so the sine of 100 equals 14 divided by the sine of 47. Following the same thing, multiplying both sides by the sine of 100. That's going to drop off on the left side. It's going to appear on the numerator on the right side, and it's going to have f equals 14 times the sine of 100 divided by the sine of 47. Do that math, okay? 14 times the sine of 100, look that up, multiply, and then divide by the sine of 47. We find that f is equal to 18.85. Again, whatever those units of measure, they be inches, they be miles, yards, feet, meters, centimeters, whatever. So we have solved this triangle. We now know what all of those angles are and all of those sides are. Okay? That's called solving triangle with the law of sines. All right, now next we'll do a real live problem. Show you what triangulation is, how GPS works.